Hello students, you're welcome to my YouTube channel, Knowledge is Power Tutorial, KPT. In today's lesson, we are going to be looking at organic chemistry and we are going to be starting with the basis. First, what is organic chemistry? I actually have a concise notes I have made here for the basis of organic chemistry, so I'm going to be running through it very quickly. First, organic chemistry is defined as the study of carbon and its compound, excluding the oxides, the carbonates, the bicarbonates, and the disulfide. So let me put it down. Okay, so this is a brief definition of organic chemistry. Organic chemistry is defined as the study of carbon and its compound, excluding the oxides, the carbonates, the bicarbonate, and the disulfide. So it therefore means that by reason of the definition we have here, one would mean that by saying that organic chemistry is the study of carbon and its compound, it will mean that every compound that contains carbon is termed to be an organic compound. But this exemption made us to understand that there are some compounds, even though they are containing carbon atom, they are still not organic compound. That is why we say that oxides, carbonates, bicarbonates, and disulfides, even though these compounds contains carbon, but they are not regarded as organic compound. Hence, they are not studied under the concept of organic chemistry. Very, very important. Another important definition of organic chemistry is that organic chemistry is the study of hydrocarbons and its derivatives. And its derivative. Okay. Organic chemistry can also be defined as the study of hydrocarbons and its derivative. So this concept of hydrocarbon is an organic concept. So hydrocarbon is nothing but organic compound that is made up of only carbon and hydrogen. So whenever we are studying hydrocarbon and its derivatives, what we are dealing with is nothing but organic compound, organic chemistry. Very, very important. We understand this. So let me quickly buttress on the first definition I've already given. I said that organic chemistry is defined as the study of carbon and its compound, excluding the oxides, the carbonates, and the bicarbonate. So a good example of oxide here, for example, the oxide we are talking about, if you are talking about oxides, we mean the carbon 2 oxide or the carbon monoxide and the carbon 4 oxide or carbon dioxide. Very important. If we are talking about the carbonates, we mean that it will be, say, calcium trioxo carbonate 3. And if we are talking about the bicarbonate, we are talking about, say, sodium hydrogen trioxo carbonate 3 disulfide. So it therefore means that these compounds, all these compounds you see here, even though they contain carbon, but they are not organic compounds. So that was why we say that they are those compounds. I mean, these are the exceptions. No wonder we say that organic chemistry is defined as the study of carbon and its compound, excluding these ones. For if we do not include this exception, it will mean that these ones are also inclusive. So these compounds you see here are considered inorganic. For if you want to study this compound, you study them under the concept of inorganic chemistry, but not organic chemistry. So a very, very, very important, these organic compounds generally are classified into the following. So we have classification, classifications of organic compounds. So we have several classifications of organic compounds. Okay, students, classification of organic compound is another important concept under this organic chemistry. It is very much important we understand how organic chemistry or organic compounds are classified. The first I have on the board is aliphatic compound, and I say that these are the open chain or acyclic compounds. So I have two examples under this umbrella. I have the propane, and I have the 2-methyl propane. So it therefore means that aliphatic compound could either be open chain or branch chain. Another important classification I have is the alicyclic compound, and I say that these are carbocyclic. These are carbocyclic or ring compounds which resembles aliphatic compound in many ways. In other words, this alicyclic resembles aliphatic. The reason is that these aliphatic are saturated, alicyclic are also saturated. The only difference between aliphatic and alicyclic compound is that aliphatic is a straight chain compound or a branch chain compound, while alicyclic is a ring compound. So a good example of the alicyclic compounds are the cyclohexane, the cyclopropane, and the cyclobutane, and so on and so forth. So the next classification I have, the third, is the aromatic compound. All right. So under this classification, we say that these are the carbocyclic compounds containing at least one benzene ring. So it has to be carbocyclic, and it must contain at least one benzene ring. By carbocyclic, we mean that it must contain carbon atoms that are in ring form. All right, that are enclosed in a ring. And being enclosed in a ring, it must contain at least one benzene ring. A good example of this aromatic compound are the benzene and the naphthalene. You can see the benzene ring as it is contains just one benzene ring, and the naphthalene contains two benzene rings. Very, very important. Finally, the fourth classification I have is the heterocyclic compound. By heterocyclic, we mean that they contain heteroatoms, and again, they are cyclic in nature. So that we now say that these are the cyclic compounds containing one element beside carbon in the ring. So a good example of these, or maybe a good example of compounds under heterocyclic compound are the furan, the tetrahydrofuran, the pyrrole, and the thiophene. So these are the classifications of organic compounds we need to know. We're going to be looking into some important terminologies in this organic chemistry. Important terms in organic chemistry. So we're going to be looking at some very important terms in organic chemistry. So the important terms in organic chemistry that I have are the electrophiles, the nucleophiles, the homolytic and heterolytic cleavage, the homologous series, and catenation. Okay, students, so now talking about important terms in organic chemistry, there are many important terms in organic chemistry. In this video, we're going to be seeing a very few of them. All right, so we have the electrophiles, the nucleophiles, we have the electrophiles, the nucleophiles, the homolytic and heterolytic cleavage. What we have for now, and we also have other ones. We have terminologies like homologous series. We have terminologies like functional groups. We also have terminologies like catenations. So, but we're also going to see those ones, maybe if not in this video, but maybe in a separate video. So, but for now, let us concentrate on electrophiles. Now, electrophiles is defined as a group of species, rather, that is seeking for electrons. That is, they are electron lovers. In the same way, nucleophiles, a nucleophile is defined as a species or group that is seeking for a proton. Very important. Let me just explain these two very quickly. Electrophiles, they are group or species that is seeking for electron. That is no wonder electrophile. So phile means loving. Electro means electron. So it means electron loving. So electrophiles are electron loving. Nucleophiles are neutron loving. No, not neutron loving, rather a nucleus loving. But it is not neutron that they love in the nucleus, but they love proton in the nucleus. For there are two entities or two particles in the nucleus. Two subatomic particles are present in the nucleus. These two subatomic particles are the neutron and the proton. The protons are positively charged, while the neutrons are not charged at all, not even negatively charged. They are neither negatively charged nor positively charged. So the neutrons are neutral, while the protons are positively charged. The electrons on the shell are negatively charged. So in the case of nucleophiles, the nucleophiles are those species that are in love with the nucleus. Now, they are not in love with the nucleus necessarily, but they are in love with protons present in the nucleus. Now, the protons present in the nucleus, they are positively charged, and hence this nucleus loving species must be negatively charged for them to love a positively charged species. No wonder like charges repel while unlike charges attract. Even that same law applies in chemistry. So therefore, electrophiles are electron loving. So since they are electron loving and that electron which they are loving are negatively charged, hence themselves, the electrophiles themselves must be positively charged. In the case of the nucleophiles are nucleus loving, or in other words, they are proton loving. So the proton which the nucleophiles are loving are positively charged, and hence the nucleophiles in themselves must be negatively charged. So in other words, or in a concise definition, one may want to say that electrophiles are positively charged species that are looking for electron, or electron deficient species looking for electron. While on the other hand, one may also say that nucleophiles are electron rich species looking for proton to give out their electrons. Very, very important to understand. So that is it about nucleophiles and electrophile. One more thing, this which I have here are examples of electrophile, which is H plus, BeCl, and H3O plus, BF3, and Na plus. So these electrophiles, they could either be positively charged or neutral. Alright, so if they are positively charged, it is an obvious case of a species losing electron. No wonder in chemistry, whenever a species loses an electron, it becomes positively charged. But those ones that are neutral, but hence still termed as electrophile, are those ones that their central atom are not octet by configuration. Very important. So in the case of nucleophiles, these are their examples. So we have negatively charged species like in these two cases, but this and this, they are neutral, but they are still termed as nucleophile. The reason is that their central atom, like in the case of nitrogen and oxygen, has excess electron as lone pair of electron. Hence, they are rich in electron. No wonder they are termed as nucleophile. So over here, I have homolytic and heterolytic cleavage. This is a very important term one needs to understand in organic chemistry. Homolytic cleavage is defined as equal breakdown of electron in a bond, thereby forming free radicals, while heterolytic cleavage is defined as unequal breakdown of unequal breakdown of electron in a bond, thereby forming ions. Very important, and these are their examples respectively: homolytic cleavage and heterolytic cleavage. So what we are trying to say is, if a bond is to be broken, it will be broken in two ways, either homolytically or heterolytically. If that bond is broken down homolytically, it is called homolytic cleavage. If it is done heterolytically, it is termed heterolytic cleavage. But very, very important we understand this. Listen, if we, by the time, or maybe if you have studied or will still study about chemical bonding, precisely under the concept of chemical bonding, there is a very important type of chemical bonding called covalent bonding. In covalent bonding, it has to do with sharing of electron between two elements or atoms. Now, in this sharing, the two participating elements or atom will contribute their electrons equally. Very important. Now, and if this electron contributed equally to form a single covalent bond, if these two electrons wants to be shared apart again, or if the bond formed by reason of contributing electron wants to be broken, it could either be broken homolytically or heterolytically. Now, by homolytically means equal breakage of the bond, meaning that if the bond breaks, the two participating elements or atom will go with the same electron they brought in the course of bonding. While if it is done heterolytically, if the bond breaks, one element or atom among the two participating elements will go with all the electrons used in bonding. Very important. But in this case now, in the case of homolytic or heterolytic, there is something very important. Homolytic cleavage will only take place between two similar elements or atoms, while heterolytic cleavage will take place between two dissimilar elements or atoms. That is why I have a good example here. So examples of homolytic cleavage are, now this, I use an arbitrary equation to explain the first one I have here, a situation whereby A bonded to A And if this bond between A and A wants to be broken, it will be done homolytically because they are same. So they will be same in terms of electronegativity. Now, what is electronegativity? Electronegativity is the ability of an element or ability of an electronegative element or atom to gain an electron and become and become negatively charged. Okay, so if these two elements are same in electronegativity, it therefore means that no one will take more electron than the other. So no wonder A and A. So A and A are same elements, hence they will be same in electronegativity. No wonder they will form these two. So this dot dot on top of these two elements simply depicts their electrons. So in this single bond that is broken, a single bond in chemistry is made up of two electrons, or in other words, two electrons will come together to form a single covalent bond. So if this single covalent bond is to be broken, these two participating elements or atoms will go with the electrons they brought in the first case. So those two electrons they brought, this one will go with one electron which I have here, and this one will go with one electron which I have here. So this is it when I use arbitral equation to explain. Now, but in this case now, this is a situation whereby chlorine atom bonds with another chlorine atom. In this case, I have chlorine molecule. If this one chlorine molecule wants to be broken, it will be broken homolytically, such that I'm going to have two free radicals of chlorine. Now, as another example is the example of heterolytic cleavage. Now, very important we understand, heterolytic cleavage will only take place between two dissimilar elements of atom. So now again, using arbitral equation to explain, this is A bonded to B. So that means that since A and B are not the same, it means that both of them must differ in electronegativity. And hence, if this bond breaks, it will not be broken homolytically, but it will be done heterolytically, such that the more electronegative element, in this case B, will go with the two electrons shared in the course of bonding. No wonder B breaks out from A having negatively charged, and A breaks out from B having positively charged. Now, this positive charge here simply means that A has lost electron, and this negative charge here means that B has gained electron. Now, using a real equation to explain, I have hydrochloric or maybe hydrogen chloride gas. Now, this bond between hydrogen and chlorine in this compound is broken, such that chlorine, being more electronegative than hydrogen, go home with excess electron, and the electron hydrogen has been taken away from it. No wonder hydrogen has a positive charge. So we are also going to see another important term, which is catenation. Another important term we need to understand as well is catenation. Like I have on the board, catenation is defined as the ability of carbon to form different types of bonds and long chain compounds. Very important. So it therefore means that this carbon in question has a unique property or a peculiar characteristics which allows it to form a strong bond and which allows you to form a strong bond and multiple bonds. Very important, or even a long chain compound. It is because carbon can form multiple bonds, that is the reason why it can form a long chain compound, which is to say that carbon has this ability to combine with other carbon atoms until it can form a very long carbon atoms. Very, very important. This chain can continue till infinity. So carbon on its own, carbon is tetravalent, meaning that carbon must be surrounded with four bonds. And all of these arms of carbon are very much ready to attach to other elements. It could attach to hydrogen, or it can attach to other carbon, and the thing goes on. So that means that this unique ability of carbon to form a very long chain and also a strong bond is termed as catenation. So dear students, I thank you for watching my video to the end. Please do well to like this video if you find it very interesting, share it to your friends, and do well to subscribe to my YouTube channel. Don't forget to comment. Thank you and God bless you. We will see the next time I will upload a new video. Thank you.